Welcome back to AI for your work. This is Tutorial 3, First Tool Using Agent. In Tutorial 2, we built an agent that could think. Today, we give it the ability to act. By the end of this video, your agent will fetch live gold prices from the web and generate a market summary. Let's go. In Tutorial 2, if you asked your agent, "What is the current gold price?" it would say, "I don't have access to real-time data." Today, we fix that. We're giving the agent a tool, a function it can call to fetch live data from the web. Same question, completely different answer. The agent will call a gold price API, get real numbers, and generate a market summary using live data. This is where orchestration starts to get interesting. This tutorial introduces 4 new concepts. First, tools. A tool is just a Python function decorated with @tool that the agent can call. Second, ToolNode. This is a pre-built graph node that executes tool calls. Third, conditional edges. Instead of always going to the same next node, the graph decides which path to take based on what Claude said. And fourth, MessagesState. Instead of simple question and answer strings, the state now holds a full conversation history, including tool calls and their results. These 4 concepts are the building blocks for every tool-using agent. Here's how the graph changes. In Tutorial 2, the graph was simple. Start, think, end. One node, one path. The agent always did the same thing. Now look at this! The agent node sends the question to Claude. Claude decides, do I need a tool? If yes, the conditional edge routes to the tool node, which fetches the gold price. The result goes back to the agent, and Claude composes a response using the live data. If no, Claude answers directly, and the graph goes straight to end. The key insight: the same graph handles both cases. The agent decides the path at runtime. This is what makes it orchestration, not just a script. First, we need a gold price API. We'll use GoldAPI.io. It's free, no credit card required, and the response includes everything we need. Go to GoldAPI.io, sign in with Google, and copy your API key from the dashboard. The free tier gives you 300 requests per month, way more than enough for this tutorial. I'm using a throwaway account for this recording, and I'll revoke this key afterwards. Even with free APIs, treat your keys like passwords. Good habit to build from day one. Let's test the API before we write any code. Make sure your venv is activated. You should see venv in your prompt. Now we use curl to call the API. Look at that! We get a JSON response with the current gold price, yesterday's close, the change, the day range, everything we need. The key fields are price for the current price, prev_close_price for yesterday, and ch and chp for the dollar and percentage change. Now we set the API key as an environment variable, same pattern as the Anthropic key from Tutorial 2. Export it for the current session, then add it to the venv activate script so it loads automatically every time. Let's verify. There it is! 2 API keys now. Anthropic for Claude, GoldAPI for live prices. Quick install. We need the requests library to call the gold price API from Python. One command, done. Now the fun part. Writing the agent. The code has 5 sections. Tool, the function that fetches gold prices. LLM, Claude, but now with tools bound to it. Nodes, the agent node and the tool node. Conditional edge, the decision function that routes the graph. And the graph itself, wiring it all together. Same pattern as tutorial 2, but with tools and branching added. Let's write it. Let's create our agent file. Nano gold underscore price underscore agent.py. First, the imports. We need the same LangGraph and Anthropic imports as before, plus 3 new ones. The tool decorator from LangChain, MessagesState, that's the new state type that holds a conversation history, and ToolNode, the pre-built node that executes tool calls. We also import requests for calling the API and OS for reading the environment variable. Now the tool. This is a regular Python function decorated with @tool. Pay attention to the docstring. This is not just a comment. Claude reads this description to decide when to use the tool. A clear docstring means better tool selection. Inside the function, we call the GoldAPI, parse the JSON response, and return a formatted string with the price, change, and day range. Notice the error handling. If the API key is missing or the request fails, we return an error message instead of crashing. Next, the LLM. This is the key difference from Tutorial 2. We still create a chat Anthropic instance, but now we call .bind_tools to tell Claude that the get_gold_price tool exists and is available. Without bind_tools, Claude doesn't know the tool is there. With it, Claude can decide to call it. Now the nodes. The agent node is similar to Tutorial 2's think node. It sends the messages to Claude and returns the response. But now, Claude might respond with a tool call request instead of a direct answer. The tool node is even simpler. ToolNode is pre-built. We just give it our list of tools and it handles execution. Now the conditional edge. This is where the magic happens. The should_use_tool function checks Claude's last message. If Claude requested a tool call, return tools to route to the tool node. If not, return end. This one function is what makes the graph dynamic. Different questions take different paths. And now, the graph. We add 2 nodes, agent and tools. Start goes to agent. After agent, the conditional edge decides tools or end. After tools, we go back to agent because Claude needs to see the tool result and compose a response. Then compile. That's the complete tool-using agent. Finally, the test section. 2 test questions. The first asks for the current gold price. This should trigger the tool. The second asks what factors affect gold prices. This should not trigger the tool because Claude can answer from its own knowledge. Let's save and run it. Here we go. Look at that first response. The agent called the gold price API, got live data, and generated a market summary with real numbers. That's not made up. That's the actual gold price right now. And now the second question. See the difference? Claude answered directly from its knowledge. No tool call needed. Same agent, same graph, but it took a different path based on the question. The agent decided. That's orchestration. Let's make it interactive. Same agent, but now with a loop so you can ask anything. Let's try, what's the gold price right now? Live data. Now let's ask, is gold up or down today? It called the tool again because it needs real-time data to answer that. Now, what drives gold prices? No tool call this time. Claude answered from its own knowledge. You can see the agent making decisions in real time, tool or no tool, based on what the question actually needs. This is the power of a tool-using agent. Let's understand how the agent chooses tools. When you call bind_tools, LangChain sends the tool name and the docstring to Claude, not the Python code inside. So when a user asks, "What's the current gold price?" Claude sees a tool called get_gold_price with a description that says, "Fetch the current gold price." The words match, so Claude calls the tool. Ask, "What drives gold prices?" Claude doesn't need live data for that, so it skips the tool entirely. This is why the docstring matters so much. A clear, specific description means better tool selection. A vague one means the agent calls the wrong tool, or doesn't call it when it should. Let's look at what's happening inside the state. The state holds a list of messages, and it grows with every step. Step 1. Your question goes in as a human message. Step 2. Claude responds, but instead of text, it says, "Call get_gold_price." That's an AI message with a tool call request. Step 3. The ToolNode runs the function and adds the result as a tool message. Step 4. Claude sees all of this, the original question and the live data, and composes a natural language summary. The nodes don't talk to each other directly. They communicate through the shared state. That's the fundamental pattern. Here are the 5 new concepts from today. The @tool decorator, ToolNode, conditional edges, MessagesState, and bind_tools. Every single one of these comes back in later tutorials. Conditional edges become multi-agent routing in Tutorial 5. MessagesState gets persistent memory in Tutorial 4. And you'll add more tools in Tutorial 6, connecting agents to real-world services beyond just gold prices. In Tutorial 4, we solve the next limitation. Right now, each question is completely independent. Ask the gold price twice, and it fetches it twice, with no awareness that it already checked. In the next tutorial, we give the agent memory. It will remember previous price checks, track trends over a session, and refer back to earlier conversations. That's where orchestration becomes truly useful. Agents that build on what they've already learned. If this tutorial helped you build your first tool-using agent, hit subscribe so you don't miss Tutorial 4. The code and the full written guide are linked in the description. I'll see you in the next one.